Hello friends. In our previous tutorial we actually discussed the depth first search algorithm of an undirected graph. So in this lecture we'll actually code the algorithm and we'll test its working. So friends, in our previous lectures we actually created one class by name graph and we have implemented the graph using the adjacency list. We also discussed the breadth first search algorithm. So in this tutorial we'll actually discuss the depth first search algorithm. So here we will be creating one method as public void DFS, and we also know that the depth first search will start from a source node. So S will represent the source node. So friends, in our previous lecture we actually saw the demonstration of the depth first search step by step. So friend, in the first step we'll simply create a boolean array. We'll give it a name as visited. And we'll initialize this boolean array with a size equal to the vertices of the graph. So friends, here we have created this boolean array which will keep the track of the nodes which we have already visited. Because while traversing a graph, there may come a situation where graph contains a cycle. So in order to visit a particular node only once, we usually create this boolean array which will keep the track of the nodes which are visited. And then we'll create a stack. So we'll import the stack from java.util package. So friends, we are using this stack which will help us in performing depth first search. And its significance we already discussed in our previous lectures. So after creating the stack, we'll simply push the source vertex on the stack. And then we'll provide a while loop. So in this value we'll provide a condition that whether stack is empty or not. So this while loop will keep executing with a condition that whether stack is empty or not. So the stack is not empty, this while loop will keep on executing. So inside this while loop, as we discussed in our previous lecture, that we pop the element from the stack and we'll assign it to u, and then we simply check that whether we have visited u or not. So if we haven't visited u, so the condition in if block comes out to be true. So first we'll mark the value at index u to be true, that we have visited this node, and we'll simply print u on the console. So friends, after visiting u, we simply provide a for loop which will iterate over each and every element adjacent to u. So friends, here after visiting any particular node, we look for its adjacent nodes, and we can get the adjacent nodes through the adjacency list, and we'll simply iterate each and every element of this adjacency list one by one. So in the for loop we simply check that whether the adjacent node to u, which is v, has been visited or not. So if the node is not visited, we simply push it on the stack, and this we do for each and every element adjacent to the already visited node. So friend, this is the code to perform depth first search over an undirected graph. Now let's test its working in the main method. So here you can see we have created a graph with 5 nodes and we have added the edges between the nodes, say from 0 to 1, 1 to 2, 2 to 3, 3 to 0 and 2 to 4. So this is the same graph which we discussed in our previous lecture. So here in the main method we simply call the DFS method and we'll pass the value of the source node as 0, that we have to start our depth first search from the node 0. So if I run the code now, so friends, here you can see it printed each and every node of the graph in the following order. First it printed 0, then 3, then 2, then 4 and then 1. So this is the same output which we discussed in our previous lecture while demonstrating this algorithm step by step. So friend, this is how we actually perform a depth first search over an undirected graph. I hope you like this video. Thanks, have a nice day.